Okay, so we've done trigonometry with right angle triangles, you know, the Sokotoa stuff. But there's also some relationships between non-right angled triangles, and there's a non-right angled triangle there at the side there. So what we would know is something about the lengths of the sides, the lengths of these sides, or these angles. We would know something about them. Alright, and if there's no right angle triangle, as far as Sokotoa is concerned, we can't use it. So if we create a construction, and that's sort of done in the dotted line there, where we make h the height of the triangle, so we create a right angle triangle there, then if we use the triangle ADC, triangle ADC, and we use Sokotoa, then h, that height, which is the opposite side, will be the hypotenuse, which in the hypotenuse is b in this case, times sine of that opposite angle, which in this case is A. Alright, so that's triangle ADC, but we can do a similar thing for triangle BDC. And in triangle BDC, the height of that opposite side would be the hypotenuse, which in this case is that, times sine of that opposite angle to H, which in this case is B. Now, when you look at that, you see that both of these, we've got H there, and looking at the triangle, that H is the same for both, it's the same length. So that tells us that B sine A is equal to A sine B. And if we do a bit of a rearrangement and write it as it's normally, you would normally see the sine rule written, you get A over sine A equals B over sine B. Alright, and basically that's it, that's the sine rule. Now of course you could split that triangle in a different way, and then of course there's another side C and sine C. Alright, so the little letters A, B and C on the top there, they're the lengths of the sides, and the A, big B, big C are the angles. And you wouldn't use all three of those, you would choose two of them. So let's have a look at an example. Alright, so an example in triangle ABC, A equals 4, B equals 7, and angle B equals 80 degrees. Find big angle A, angle C, and side lengths. Alright, so let's draw this thing. So here we've got A, B, C, doesn't really matter. A is that side opposite angle A, so there we are, 4. B is the side opposite angle B, there we are, 7. Angle B, it's 80 degrees. Alright, so we're looking to find, in the first part, we're looking to find angle A to start with. So what the sine rule is the angle, sine of the angle, and the side opposite that we're using. So in this case, we've got angle A, of course, and we've got side A. We've got angle B, and we've got side B. So the bits that we were we would look at taking is A on sine A equals B on sine B. Alright, and put in the numbers, so we've got 4 on sine A equals B, which is 7 over sine 80. Alright, bit of rearrangement, so flip both sides first of all. Sine A over 4 is sine 80 over 7 times by 4 both sides. Sine A is 4 sine 80 over 7, so A is sine minus 1 of all of that stuff, and you can do that all in your calculator. And so when you do all of that in your calculator, you'll find that A is 34 degrees and 15 minutes. Alright, so there's that, we found that bit. The next bit we're going to look for is angle C, and given that this is a right angled triangle, that means that angle A plus angle B plus angles, not a right angled triangle, I'm talking about a triangle. Internal angles have got to add up to 180. Alright, so when you do that calculation, you find that angle B is 65 degrees 45 minutes. Alright, then finally we're asked for side C. So side C is this one. So we need to use angle C because that's opposite. And then we can choose, we're going to choose those because we've already given those. So the bit we're going to use is C over sine C equals B over sine B. And C is what we're after, sine C, that's 65 degrees 45 minutes, equals B, B is 7 over sine 80. So C then, bit of rearrangement, C 7 sine 65 degrees 45 minutes over sine 80. You can do all of that in your calculator. Don't forget, you've got to tell the calculator that the angles in degrees and minutes. Okay, so you need to tell the calculator that, otherwise the calculator just thinks it's a decimal. If you're not sure how to do that, make sure you ask, but it's in the transformation menu, DMS. Alright, and when you do all of that, you get 6.48 metres. Alright, that is it for the sine rule. However, there's always a twist, and the twist here with this is there's a thing called the ambiguous case. Okay, so when we get a triangle, and it depends on the information that we are given. So, say for example, in this case, for this ambiguous case, if we're given this angle in here, we're given that length there, and we're given this length A. There actually ends up being two possible triangles. Alright, because if we take C and pretend that's the centre of the circle, we've got one there, and we swing that around there, because we may not, well, we haven't been given information to tell us how long this line here is. So if we take that side A, this one here that we've given, and we swing it around, it's going to intersect that purple line in two places. So the dilemma that we have then, is the triangle we're looking at this one, or is the triangle we're looking at this one? Because both of them. Alright, so that's our ambiguous case. So basically what that ends up meaning is that we can have two different options for this angle down here and two different options for that length there. Alright, but something else that we do know. Now let me get rid of all of those drawings. There is something that we do know about that triangle. This triangle I'm referring to. What do we know? Now that's already telling us that that and that are the same length. So if they are the same length, that is what we call an isosceles triangle. And isosceles triangles, not only do they have two sides the same, but they too have two angles the same. Those two. Now when we put it on our calculator is always going to give us this one. Right? So if it gives us this angle here, always, then we know that one opposite, and then by 180 minus, we can work out that. Alright, so let's do an example. There's a lot of talking there and not much action happening, so let's do an example. Okay, so our example, let's get rid of all of that, clear all. Okay. Right, so it's indicating, because it's telling us to find two possible values for A, it's already indicating to us that it is an ambiguous case. Alright, so here's our triangle ABC. It's telling us side A is 10, so that's 10. Side C here is 6, okay, not to scale, not to worry about that, don't worry about whether it's to scale. Side C there is, angle C I should say, is 30 degrees. Alright, so it's this side over here, it's this side here, side that we could swing around, okay. And yes, we could swing it around and intersect there and then over here somewhere. Alright, so let's get rid of those last two constructions. So, and two possibles for angle A, so we're looking for those two there. Against sine rule. And the sine rule is, the ones we're using this time is A over sine A equals C over sine C. So 10 on sine A equals 6 on sine 30, do the old flip to get the angle on top. We're rearranging, then A is sine minus 1 of 10 sine 30 on 6. And when you do that, you get 56 degrees and 27 minutes. Alright. Okay, so that's one of the angles. Now, remember, I said before, and it's not going to work out on this one because my thing's real bad. My triangle, the way I've drawn it's real bad, but remember, that's 6 and so is this 6. So it makes that an isosceles triangle. So that angle A we've found and this angle in here that we found is also the same. So we need to be finding that bit in there, and that red bit in there is just 180 minus the one we've just found. Alright, so that's always the case. And 180 minus that is 123 degrees and 33 minutes. And there is the ambiguous case. Alright. You can use that on, do your calculator to do this sort of stuff. So there's an instruction in your textbook. Alright, there's quite a lot in this exercise, so we're just going to do the odd numbers, exercise 5C. Alright, so odd numbers, see how you go with that.